students, so in this unit we are going to talk about the quantum numbers and what actually the quantum numbers are. So let me explain you. Quantum numbers, basically it says that we have four quantum numbers, and we have four different quantum numbers, okay? And it says that no two electrons can have the same identical values for all these quantum numbers. So indirectly what it says that the quantum numbers can help us to uniquely identifying any electron. So we identify the electron uniquely. It's similar to like passport. Every individual, they have their own passport number and it should not match with any other one. Okay, so this is quantum number. Okay, so how we do it, what are the different quantum number, what they actually mean, and how we find the quantum number value, that is what we are going to cover in this unit. So we have four quantum number. First one is principal quantum number, and it is represented with the help of n, and its value is always 1, 2, 3, 4 and so on. So it basically talk about the energy level in which the electron is residing and what it actually means. So we have a nucleus here, then we have these are called energy level. First energy level, second energy level, third energy level. So for this one we write n1, for this we write n2, and here we write n3. So in which the electron is lying, we call that as a principal quantum number, where the electron is present. Is it in the first, or is it the second, or is it in the third energy level? Okay. Second is angular momentum quantum number, and it is represented with the help of L. Angular momentum quantum number, and it is represented with the help of L. So it basically talk about the orbitals. Okay, so it basically tell us that in which orbital the electrons are lying, and the value of L is always starting from 0, it will go maximum to n minus 1. So like say if your energy level is say n is 3, then L can have value either 0 or 1 or 2, but L can never be equal to 3. Okay, so at L is always 1 less than the n value, and these are all integer values. Okay, now what exactly this L means? It talks about orbital. It's orbital. And orbital, what actually they are? We have different types of orbital. We have like s orbital, p orbital, d orbital, f, and then further we can think of g and h also. We don't have those many yet, but we can think of. If you just want to understand this concept, assume it like, you know, the different kind of the houses. Like S, you can assume it like say maybe condo, and P maybe like, you know, townhouses, and D may be like semi-detached, and F is maybe like detached houses and so on. Now you know that each house, they have their own capacity, their own properties. Okay, so basically these orbitals, they have their own properties. For example, when we talk about s orbital, it means it can accommodate only 2 electrons, and it has only one room, and we call it as subcell or suborbital. When it comes to P, we have 3 values, means there are 3 rooms, and each room is occupying 2 occupants. So that means it can hold 2 electrons here, this can hold 6 electrons. And when it comes to D, then it can hold 10 electrons because it has 5 subcells. Okay, so that is how we figure out the value of L, and you know the name of these subcells we write like this. So L is means 0 means S. So if L value is 0, that means S. If L value is 1, that means P. If L value is 2, that means D. If L value is 3, that means F. Okay, and so on. If L value is 4, that means G, and we don't go that far. As I told you, we only have 100 plus element right now. Okay, so this basically tells you that in which orbital the electron is. Okay, is it in the s orbital or p or d or f? Okay, that's your second quantum number. Third is your magnetic quantum number. Magnetic. magnetic quantum number. And magnetic quantum number, it talks about basically the subshell where the electron is there, where the electron lies. Okay, where the electrons. Okay, so subcells means, you know that I told you D have 5 rooms. Now the electron is in which room? Is it in the first room or in second or third or fourth or fifth? So it talks about that, the distribution of electron among those shells. Okay, that's called quantum number, magnetic. And how we figure out its value? It is represented with the help of ml. And for any given value of L, it starts from negative L through 0 plus L. Like think of, they give us the L value as 2. That means the possible value of ML are negative 2, negative 1, 0, plus 1 and plus 2. Okay, and same way, if they have given say ML as 1 or say L value is 1, then it is just minus 1, 0 and plus 1. Now these values are significant, students. Okay, so how? Because I said when L is 2, then these are the values. Now count how many values we have here. 1, 2, 3, 4, 5. Now please come up and see this. When L is 2, it's called d orbital. And when you come to D, you know you have these 5 locations. So we just number them. This is negative 1. Sorry, this is negative 2, negative 1, 0, plus 1 and plus 2. Same way, when I said when the L value was 1, we said that we have 3 possibilities of subcells. So that's again we are going to write negative 1, 0 and plus 1. But if L value is 0, that means ML value is also 0. So it talks about the subcell where the electrons are lying. Okay, and then the fourth one is your spin quantum number. Spin quantum number. And spin quantum number says that under any subshell, means in any room, if there are 2 electrons, they will have opposite spin. So one electron will have ms plus half, second electron will have ms as negative half. Make sure we have to write here plus half. So it's not like math where we just write 1 over 2. That plus means just 1 over 2. No, you have to write here plus. So plus half and negative half. Like for example, I assume that upper spin is plus 1 or plus half. That means lower spin is negative half. So in any subshell, we cannot have 2 electrons which are pointing in the same direction. It's wrong. They will be pointing in the different direction, means they will have opposite spin. So these are the different values that help us to figure out or to identify one electron uniquely. Okay, uniquely identify one electron. Now we will move further and then we'll talk about some principles of filling the electrons. So you can see we have some principles here. Pauli's exclusion principle. It says that no 2 electrons in the same atom can have identical values for all of their 4 quantum numbers. So that's the basic rule. It says this is principle of Pauli's exclusion, and there is no more than 2 electrons can occupy the same orbital, and if we have those, they will have the opposite spins. Okay, so second is we have a rule here. Let me look into some rules here. These are. So one is a Bose rule. It says that lower energy orbital fill before higher energy level. And this is the way our energy levels are organized. Is 1s, then 2s, then 2p, then 3s, then 3p. This is how it look like this. This. And again, you are going to come back. Okay. And when the number 1 means your n value is 1. And when this number is 2, that means n value is 2, and so on. So say this, the way the electrons are filling. So I cannot fill 2p before I fill 2s. That is the meaning. This is what the above principle says, that lower energy level need to be filled before higher energy level. And Hund's rule, it says that if we have multiple electrons going inside any same level of suborbitals, then the pairing will not start unless or until all the cells are singly filled. Okay, so I will explain you also this, what this actually means. So for example, you can see here, see 2p. Now you know p means there are 3 cells. So P means there are 3 shells. Now what we have done here? So in this second example, you can see we did not take this electron to the third shell and we start pairing it before. So that's wrong. It says that first you have to distribute electron equally, and when they have been equally distributed, then you can come back and then you can start pairing. Okay, so these are the rules that we have to use, and then we have to find the quantum numbers for the given values. Okay, so let me see if I have some question based upon it. So let me have a look on that. So should be there, hold on. Quantum numbers, we have this quantum number worksheet. Let us open it. I will try to do some questions here. They're saying give the n and l value for the following orbitals. Okay, so here let us take an example of this. So we are talking about 4d. Now the value of n in this case is 4. The value of d, the value of l can be, any value between 0, 1, 2, 3. These are the possible value. Now for 0 means S, for 1 means P, for 2 means D, and then for this one is F. Now because they are talking about D, that means here L value is 2. So you have to write L value is 2. Okay, I'm going to give you an example of, say, let us talk about, say, oxygen. Okay, and its distribution of electron. That will come under the heading of electronic configuration. We'll do that soon, but right now I'm just doing it. So say we are going to talk about last 2 electrons of it. So last 2 electrons, how the values of those quantum number will be there for these last 2 electrons. So you can see our electron will be distributed here. In oxygen we have 2 electrons in the first shell, then we have 6 electron around it. Okay, so if you look into the electronic configuration stuff we are talking about there, so let us go back and how the electron will be distributed. It says you have to start from 1s and 2s. So let us start from 1s. So it says 1s and we are going to say 2 because s can hold maximum 2 electron. Again remember, s has only one shell and it can hold maximum 2 electrons. So we said 2. Now next is here, you can say next is 2s. So I will write now 2s, and also it can hold 2 electrons. Okay, and we also have to count for oxygen we have 8 electrons. Okay, and the next we have is 2p, and so I will write 2p. It can hold, p can hold maximum 6 electron. Why? Because it has 3 rooms and each room can hold 2 electrons. So 6, but if I put 6 here, then it will make 10. We don't have 10 electrons. So we are just going to write here 4. So 2p4. Now, when you look into how they look like, 1s, they look like this. 2 electron. Similar, this I'm talking about 1s. And then 2s, we are going to talk about, sorry, I should have written 2s here. So the electrons are again like this. And then we have 2p. 2p, you know that we have 3 rooms. So first keep on distributing 1 electron and then start pairing it. So basically the electron which they are looking for is here and here. These are the electrons they are looking for. So let us talk about this electron first. So the n value is whatever number you see here at the beginning. So n is 2. L will come from the name P. So P, you can see the L value will be in that case. So where we did that, yeah. So P, if P is there, L value is 1. So we have to write L as 1. And then ML. ML, now you can see, you can give this number -1, this is 0, and that's +1. So I'm going to give it, say, +1. And then MS means what is the spin? I'm going to write it +12. Now this was for, say, A electron. I'm going to mark it A. Now we have to do for B. B means this electron. So what is there? N value is again 2. L value is again 1. ML value in this case, I'm going to write -1. And MS value in this case, I'm going to write, it's spinning down. So I'm going to write it -12. Now you can see they cannot have same values. They're different values. So you can pick any two electrons and they will have the different quantum numbers. Okay, so I think that's all for this unit, how to figure out the quantum numbers and how to solve them. Thank you.